Yo, what up, YouTube? Welcome back to another episode of Learn with EarthquakeDude. Today, we're going to be going over lesson 7, which are the different types of plate boundaries. Very good talk today. So, make sure to guys follow me on TikTok, Twitter, Instagram, earthquake_dude. Come show some love. And without further ado, let's begin our lesson on the different types of plate boundaries. We're gonna start off with the most common plate boundary, and that one is called divergent plate boundaries. Now, divergent plate boundaries are when the two tectonic plates are moving away from each other. And when that happens, you have magma that rises up and fills that gap. It then cools and solidifies into new young rock. This one being basalt, right? Now, most divergent boundaries are found along mid-ocean ridges. Now, if you don't know what a mid-ocean ridge is, it's basically a submarine volcanic chain. And most of these are underwater, so we don't really associate or interact with them. But the idea here is that hot material rises up below, bulging up the crust into the submarine mountain chain. That magma touches the water and instantaneously cools into the new rock called basalt. So the main thing you want to take home here is that that divergent plate boundaries are literally just moving apart from each other, moving away. Okay? So let's look at a map. All these mountain ranges you see here in the ocean floor, those are divergent plate boundaries or mid-ocean ridges. Now remember, mid-ocean ridges are only associated with divergent plate boundaries. Okay? Now, understanding the tectonic regime that you see here in a divergent plate boundary, you know that the plates are pulling apart, right? That's what we call extensional stress. And in that type of setting, you get normal faults because normal faults are being pulled apart as well. Extensional stress creates normal faults. So it shows you how faults and plate boundaries go hand in hand. Now, the second type of plate boundary, and probably the most dangerous one out there, is the convergent plate boundary, and that's when two tectonic plates are colliding with each other. So they're moving towards each other and they collide. Now, if one of the plates is carrying oceanic crust, it may sink back down into the mantle along a subduction zone. Now, subduction zones are very important, and subduction zones only happen when one of these plates is being pushed back into the earth. You create a deep oceanic trench, and that's that location where the plate is bending, being pushed back down into the earth. So you can see here in the diagram that this area right here, that is the whole subduction zone, and that is the oceanic trench. Now, one thing to keep in mind, whenever you have oceanic crust come into contact with either other oceanic crust or continental crust, the oceanic crust always subducts under the other plate, and that's because of the density differences. But what happens when two continental crusts come together to collide? Which one sinks? Well, continental crust cannot sink. It's just not dense enough. So instead, what happens is when two continents collide, a big mountain range is formed instead of a subduction zone. And there's one really famous place in the world that has a continent to continent collision happening. Anybody know? I'll give you 2 seconds. If you said the Himalayan mountains, you are correct. India crashing into Nepal and China, creating the large Himalayan mountains, is a continent to continent convergent plate boundary. Very good. So let's look at the map. So all these places here with the orange arrows are showing you oceanic trenches in which are associated with convergent plate boundaries. And if you look here, there's India, there's China. That's the continental collision that you see there, creating those big mountains because of that continent to continent convergence. Very cool, huh? Okay, so what type of fault would be associated with a convergent plate boundary? Remember, convergent plate boundaries, you have the two plates that are crashing together, meaning you're compressing the region, in which case you get reverse faults, because reverse faults form from compressional stress like at a convergent plate boundary. So far so good, right? Now, convergent plate boundaries are they're the plate boundaries with the largest earthquakes in the world. The top 4 earthquakes in recorded history all occurred on convergent plate boundary. 1960 Chile, magnitude 9.5. 1964 Alaska, magnitude 9.2. 2004 Sumatra, 9.1. 2011 Japan, 9.0. All on convergent plate boundaries. So these plate boundaries attribute to the largest and biggest earthquakes in the world. Plus, you get the tsunami feature as well. So just, something to keep in mind. Now, the last type of plate boundary is the transform plate boundary. And the transform plate boundary is the chillest. It's just the normal boundary. It really does nothing but move the two plates horizontally past each other. Now, transform boundaries can be either found in continental or oceanic crust. They're very, very common in the ocean, basically cutting off mid-ocean ridges. But there are a couple spots in the world where they're actually found on continents. A very special one is actually a transform plate boundary, which we'll talk about here in a second. So, horizontal movement. As a result, you get this shearing stress that's being created from these transform boundaries, and the types of faults that are associated with transform plate boundaries are going to be your strike slip faults, your left lateral and right laterals, depending on the sense of motion. But those faults, the strike slip faults, are associated with the transform boundary. They literally move the same way. They're pretty much the same thing. So pretty easy to remember. Now, I did mention that most transform boundaries are in fact in the ocean, and that's true. In between the mid-ocean ridges, you see these large transform boundaries that are splitting them up. And they're very, very, very common in the ocean floor. But like I mentioned, there are a couple on the Earth continental crust that exist. For example, the SAF, the San Andreas Fault, right? There's also the Alpine Fault, which are two of the biggest examples of large transform boundaries on the continent. But you can see in the ocean floor, these large red lines here represent large transform boundaries in between the mid-ocean ridge. Okay, there you have it. The three types of plate boundaries and what faults are associated with them. And now you know your plate boundaries, and now you understand why specific size earthquakes occur in the specific types of plate boundaries. So that brings us to the end of lesson 7. I hope you guys enjoyed it. I hope you learned something new. As always, if you have any questions, please drop them in the comments below. Don't forget to like, comment, and subscribe. I know this lesson took like 2 weeks to put out, but things got really busy. But I will be posting lesson 8 very, very soon. Again, thank you so much for watching. Make sure to follow me on Twitter, Instagram, TikTok, and I'll see you guys in the next lesson.